Hey, so we're going to talk about what are piecewise functions. So let's just go right into that. What is a piecewise function? So we're not really that clever in math sometimes and how we name things. It's a function in pieces. That's how I think of it. So it looks like this. So it's literally like two different functions, and the pieces, the way that the pieces are described, are by this notation over here. So I'm going to explain all this to you, and then I just want to show you like what they can look like. They kind of have these like wacky looking graphs. So in this case, this is a piecewise function that has three pieces. So you could have as many pieces as you want. So we're going to learn all about this in this video. So the first thing that I want to teach you, how does this notation actually work? Like, how do you read this? What do you do with this? Okay, so I have this piecewise function example here. Here are my two functions. So when I plug something in, if that value is greater than or equal to 2, I use this function. If that value is less than 2, then I use this function. So I want to evaluate f of 3. So what I would say then is f of 3, so that falls into this category, right? It's greater than 2. So when I want to evaluate this, I go 3 times 3 minus 1, so that becomes 9 minus 1, which equals 8. Okay. So now what about f of negative 1? Well, when I look at this, so I have negative 1, so that would fall into this category, right? Negative 1 is less than 2. So I'm just going to plug that in. 1/2 times negative 1 minus 4. So that's going to be negative 1/2 minus 4. So I could call that negative 4.5, I guess. I'll just call it negative 4.5. All right. Now, what about f of 2? Which one does that go to? Well, 2 is equal to 2, right? So it actually falls into this condition here, so I would use this function. And so then this becomes 3 times 2 minus 1, so that's 6 minus 1, which equals 5. All right, so that's kind of how you evaluate these. I have another function here that I thought maybe would be cool for you to try. So maybe just pause for a second, think about this for a moment, and then hit play if you think you've figured it out. So, okay, f of 4. So 4, when I look at my conditions here, 4 is greater than 3, falls into this condition. This is just a constant function. F of 4 equals 4. I don't have to do any math. It's just 4. That's it. That's the answer. All right, now f of negative 5. All right, so I look through my conditions. Negative 5 falls into this condition here. So let's see, I can plug in negative 5 squared minus 5. So this becomes 25 minus 5, which is 20. Okay, let's do two more related to this. So again, pause here. Math is not a spectator sport. If you're trying to get the most out of this and you're learning this for the first time, you'll get more if you actually try. Hit play when you're ready. So, okay, negative 2 equals negative 2 falls into this condition here, right? So this will be negative 2 squared minus 5, so that's 4 minus 5, so that equals negative 1. And then f of 3, so here's where x is equal to 3, right here, this condition. So I plug it into this function here. So this becomes 4 times 3 minus 2, so that's 12 minus 2, which will equal 10. Okay, so I think we've got the idea now of how to evaluate them, so now we will graph them. And this can seem a little tricky, so we're going to do a whole bunch of examples. So I want to start with a super basic example so that we can really focus on how do you get these pieces. Okay, so I've got this piecewise function. My pieces are 4 and negative 1. So these are just straight up constant functions. So they're just horizontal lines, okay? So the thing that I really want to focus on then is this part right here. So this is kind of like your breaking point. And so the methodology when you're graphing, if you have less than or greater than, or greater than or less than or equal to or greater than or equal to, you use a closed dot. When you have less than or greater than, you use an open dot. Now the thing that throws everybody off is that you actually need these dots here. They since I'm going from x is greater than 5 and x is less than or equal to 5, I'm going to have two different dots here at 5. And so let's think about that. So starting at x is greater than 5. Okay, so let's find that. So 1, 2, 3, 4, 5. So I'll just go ahead and mark that. So 1, 2, Here's 5. So just to make my life easier. Okay, so when the x's are greater than 5, so which side is that on? Is it on this side or is it on this side? The x's are greater than 5 over here. I need to have the constant function 4. So I'm going to come up to 1, 2, 3, 4. So let's see, 1, 2, 3, 4. And I'm going to put an open dot here. And then I want to go in the direction that the x's are going. So x is greater than 5, so that would be this constant function here. Okay, now for x is less than or equal to 5, I need to be here at -1. So let me erase this 5 now. So here's -1. So since this is x is less than or equal to 5, I am going to put a closed dot here. And then where's the less than direction? It's everything going this way, right? Pretend that's straighter. Okay, so there's usually a couple questions with this. This is the graph, but why is it that I had to put a dot here at 5? Because it says that 5 is not included. So think about what it means to be greater than or equal to 5. This means that we want to get as close to 5 as possible without actually touching 5. So what that means is, so just to make this nice and clear, we would have to also include 5.1, 5.01, 5 with 0.00001. You could have like 100 zeros and then a 1. So to the human eye, like it will look like we're basically at 5. We want to be as close to 5 as possible without actually touching it. So we have to be able to like absorb all of these possibilities here. So to be greater than 5 doesn't mean that we start at 6. It means that we need to get as close to 5 as possible without touching it. And the mathematical way of expressing that is to use an open dot. So there's a dot here at 5 where the function kind of switches off. That's kind of how I think of this, is that this is like the switch off point. So I go from 1, boop, up here, boop. And so that's the way that we kind of want to think about this. Okay, so let's keep going. Okay, so now I have slightly more complicated functions here, and we have this kind of break off point at -3. So there's a couple different ways that you can graph this. So one thing I like to think about before I go too far with this is I like to think, what kind of graphs are these? So 3x plus 1, this is a line, right? And -2x is also a line. So at -3, this is where we need to jump from one line to the next. So I need to know what's happening at -3 for both of these. So what I'm going to do is, let's see, I will start with this function here. So let me just plug in -3. 3 times -3 plus 1. This is -9 plus 1, so this is equal to -8. Okay, so I'm going to go ahead and I'm going to need the point -8. So let's go ahead and let's go ahead and mark this. So -3, -8. So here's, let's see, -3, 1, 2, 3, 4, 5, 6, 7. Oh, I need one more point. Let me mark down there. Okay, -3, -8. Okay, so I've got the point. Should this get a closed dot or an open dot? This will get an open dot because 3 is not included. So I need to mark this first. Now I need to go in the x is greater than -3 direction. So is that this way or this way? Greater than -3 is over here. So I just need to get to the next point. There's two ways that you can do this. So I'll show you the first way here. So I can just use the slope, right? And go in the direction that is greater than. So what I could do is I could take this point and then the slope is 3. So from here I could go up 1, 2, 3 and over 1. 2, 3 and over 1. So I could do it like that. The other way I could do this, which is going to give me the same result, is I could choose a point that's on this side, x is greater than -3. So I'll erase this for a second just to show you. So a point that is on this side of -3 would be -2. So I could plug in -2 into this function. So I get -6 plus 1, so this equals -5. And then I could go ahead and just plot -2, -1, 2, 3, 4, 5. It's the exact same point I had before, right? So tomato, tomato, whichever method you like better. And sometimes you don't have a simple function, so you have to plug in a point. So you can kind of just think through which way you want to do this. Okay, so now I've got the first part of this graph. Cool. So now I've got to do the next piece, -2x. So let me clear some space. All right, so once again, I need to know what's happening at -3, but now on this piece of the function. So I'm going to have -2 times -3, that equals just +6. So first I'm going to plot that point. So -3, +6, 1, 2, 3, 4, 5, 6. Does it get a closed dot or an open dot? It gets a closed dot, right, because it's got a less than or equal to. Okay, now I need to make sure that I'm going less than or equal to 3. So is that on this side or this side? It's on this side. So again, I have two ways that I can do this. I can count out the slope. I just have to be careful though, because normally when I count out the slope, I'd go down 1, 2, and to the right 3. And I don't want to go to the right this time, right? So I'd actually have to back up that direction and go up 1, 2, and over 3. So just be careful if you're going that way. Or if you're paranoid about it, you can always just choose another point that's on this side. And I'm going to be paranoid about it, and I'm going to just choose another point that's on this side. So another point over here would be -4. So if I plug in -4, I get +8, and I need to just extend my graph one more. So -4, +8. There's my 2 points to make my line. There we go. We've got our graph. Okay, so I want to keep going with this idea, and now I'm going to extend this to a three-piece function. All right, so starting with the first piece. So x is greater than 2. So this is just a constant function. So I think that you know how to graph this. So plot the point. This is just the constant function 3. I want you to pause and try to just graph this first piece on your own and hit play when you think you've got it. So I need to graph this where x is 2, and this needs to be an open dot at x is 2. So here I am, here's x is 2. I'll come up here to 3, so let's see, I will put open dot there. Now I need to go in the direction where x is greater than 2, so that's this way. All right, so we've got one piece down. Cool, so now we're gonna move to the middle piece. And so what's interesting about this now is that I have kind of a start and a stop with this middle piece. So I need to know what's happening at both 2 and -1. So let's figure that out. I've got 2 times 2 equals 4. So I'm going to plot the point 2, 4. Here's 2, 1, 2, 3, 4. Does 2 get a open circle or a closed circle? 2 is included on this part of the function, so it gets a closed circle. So go ahead and mark that. And then we have to figure out what's happening at -1, right? Because -1 comes from here. So 2 times -1 equals -2. So now I have to mark the point -1, -2. And does that get a closed or open circle? So if I look at this, -1 is not included, so it gets an open circle. So -1, -2. And 2 points determine a line, and that's just a line. So actually now I have the 2 points that I need, and I've got my second piece. Okay, so now I want you to try to do the last piece on your own. Pause the video. Now it's not a spectator sport. Give it a try. Hit play when you're ready. Okay, so I've got to know what's happening at -1 for sure. So I'm going to have -1. Make sure you got that double negative right. So this just becomes 1 plus 3, which is 4. Okay, so here's -1, 1, 2, 3, 4. And so does this get a closed dot or a open dot? This is closed. And then I just need to get a second point for this line. I'm just going to choose a point that's over here because I get a little nervous. So I'll choose -2. -1 or -2 plus 3. This is going to equal 5. That's -2 and 5. And there's my last piece. All right. Okay, so I've got one more here for you, and now this is kind of a test for you to see how this is going. So I think you should pause the video, try this totally on your own. Remember, if you get stuck or if you get it wrong, like there's no shame in that. That's how you learn. But you're not going to get as much out of this if you just watch me do it. If you're trying to learn this, you've really got to pause and think about it on your own. And then if you right or wrong, the next part of the video will mean more to you because you engaged with it. So pause here, give it a try, hit play when you're ready. All right, so I've got to know what's happening at 1. So I'm going to plug 1 in. So that gives me 4. So I need to mark the point 1, 4. And I'm going to make that a closed dot since 1 is included. So let's see, 1, 4, boom. And then I want to just get another point that's greater than 1, or I could count out the slope. You know what? I'll count out the slope this time. Why not? So I'll go up 1, 2, 3 over 1, boom. Okay, so I've got that part done. Up next, I've got the constant function 6. This goes from -1 to 1. At 1, I have an open dot. So let's see, 1, 2, 3, 4, 5, 6. So this is going to be an open dot here, and a closed dot at -1. And it's just constant, so boop, there we go. Okay, and for the last function, now I need to know what's happening at -1. So let's see, I'll clear this out. So I'm just going to plug in -1 into x squared. -1 goes into x squared, that just equals 1. So I'll mark that point. That's going to be an open circle, right? So -1, 1, open circle. And then this is a parabola. So I know that a parabola is going to kind of have like a U-ish shape. I'd like to find another point here just to kind of guide me. So I'm going to just choose, how about -2? So I'll just plug -2 in because it's on that side. So -2, 4. All right, and then I can just kind of go that way. And so I tried to curve that a little bit. So with my scale, it might not look totally curved, but it's got a little bit of more of that U-ish curve. If I were to continue the parabola, this would make it look more like the actual U that it is. The dotted line that I just kind of sketched out there, but that's not what we're being asked to do. So it's not going to have like a super clear U shape, if that makes sense. Okay, so hopefully now you kind of get the idea with piecewise functions. So if you found this helpful, please consider liking the video, leaving a comment, subscribing to the channel. And that covers it for this video, guys. If you have any questions, you can always drop them in the comments, or you can email me. I will talk to you next time.